So I had posted a problem statement in which you had to calculate the running total for the last 7 days, and that was to be bifurcated or partitioned for each employee. You had to solve this using SQL, and I had given a hint that you can use the window function for it. I'm going to solve this problem statement using 4 different ways. I'm going to use Excel, I'm going to use Python, I'm going to use SQL, and I'm going to use Power BI. So without further delay, let's get started. So this is how our data is going to look like. We have the sales ID column, the sales date, employee ID, and the amount. As you can see, for a particular day, an employee can conduct multiple sales. So first, we need unique values for each employee and each date, right? And when we talk about the cumulative or total sales for the last 7 days, what does it mean? So for employee ID 100 on 16th of August, we need data between 16th and 10th. If we also include 9, that will be 8 days, right? So first, what do we need? We need a unique combination of employee ID and sales date. And for that, we are going to use the unique function in Excel. I'm going to choose both the sales date and employee ID column. And I got my unique values here, right? I'm going to specify the column name, which is sales date and employee ID. Now I need the total sales. So for employee ID 100, for this particular row, we need the sum of amounts between 16th and 10th, right? These dates, for these dates, whatever sum we need to specify that here. For this, we are going to use sum if s function that allows us to give the sum of a particular range based on multiple criteria. So the first parameter is sum range, which would be our amount here, right? Now, what is our first criteria? For this particular row, we only want to consider the rows where the employee ID is 100. So our first range would be employee ID, right? And the criteria would be this particular cell, which would be 100. What is our second criteria? So for the second criteria, we need dates that lie between 16th and 10th, right? So our criteria range would be sales date. And what is our first criteria? Our first criteria says that the sales date for this particular row should be greater than equals to 10th, right? Now we are not going to hard code it, obviously. What we are going to do is we are going to subtract 6 from here. So essentially what we need to do is we need to specify where it is greater than equals to, and we will concatenate this with this value right here, or this column cell value right here, minus 6. So now we have told Excel that only specify dates where our sales date is greater than equals to this date minus 6. We need another criteria because our sales date should be less than equals to this. There is a possibility, for example, we need to replicate the same formula here as well. So if we do not write the other condition, the between condition, it will consider these dates as well. So we will again choose our sales date as our criteria range, right? And this time we will specify less than equals to, the other condition is this value. So it should be greater than equals to minus 6, our lower bound or our lower range, and should be less than equals to this particular value, right? Right here. Let's close this. And we got the value as 543. Let's validate this. So between 16th and 10th, these rows, the sum is 543. Now all we need to do is double click here and it's going to populate all the values. So using Excel, we were able to solve this using unique, and some ifs, right? Let's move to SQL and see how we can solve it using a query. So I'm using Oracle Live SQL here. I'll leave a link to it in the description. I will also leave the link to the DDL and the DML statements. So this is our sales table. Okay. Now the first thing that we need to do, as we did in Excel, is to get a unique combination, right, of our sales state and employee ID. And we are going to do that with the group by statement. So we are going to specify sales state and the employee ID, right? And we are going to take this sum of amount and let's call it employee underscore sales. I'm going to group by these two. And what this is going to give us, it is going to give us the sales of the individual days done by the different employees, right? So we got our output on 27th August 2024, employee 103 has done a total sales of $41, right? That's what we get from here. Now I'm going to use the with clause to solve it. So I'm going to specify with, let's call this our sales underscore data, with sales underscore data as, right? And let's run it to verify if everything looks good. Okay. I'm going to give it an alias S. And now what we need to do is we need to get the cumulative sales, but only for the last 7 days, right? So our range should be between current day -6 and the current day, right? And we need to partition by employee ID. So for this, we are going to use the analytical function. We need the sum of employee sales. I'm going to specify here. Then I'm going to specify over. We will partition by the employee ID, right? We need to partition the sales based on the individual employee. We are going to order this by the sales date. So we want the previous sales date, right? The previous 7 days. And then we are going to specify range between. So our range should lie within the last 7 days. And for that, we need to specify 6, right? And we want this to be on the basis of days. So our range should be in the last 7 days. So it should be between current row and 6 days previous to that. And let's call this total sales. Let's run it. And we got our answer. So we know that it was 543 for the employee ID, 100 for the most recent date, right? So let's quickly verify that. I'm going to order by employee ID ascending, and I'm going to order by sales date descending. So this should show. So for the 100th employee ID on this particular day, it is indeed 543. So it is returning the exact same result that we saw in Excel. So again, the same problem statement can be solved through Excel, can be solved through SQL. Let's go ahead and move to Power BI and solve it in Power BI as well. Okay. All right. So this is my Power BI desktop and I've loaded the data already. So we have 1000 rows and our 4 columns: ID, sales state, employee ID, and amount. So first I'm going to drag employee ID and sales state in a table. Okay. I need the individual dates. So this basically gave me a unique combination of the employee ID and the sales state. Before we go ahead and create our cumulative measure, let's just quickly see the amount as well, how it looks like. So this basically indicates that on 30th of August 2024, the employee ID 100 did a total sales of $194. Now let's go ahead and create our measure. So for those who understand Power BI, they know that we have a filter context here. So right now in this particular row, Power BI is automatically filtering only those rows or taking the sum of only those rows where the employee ID is 100 and the date is 10th of September 2024. But in order to calculate our cumulative sums, we do not just need that particular row, we also need the last 6-day rows from that particular day, right? So we need to break this or modify this filter context. And for that, we have the function calculate and filter in Power BI. So I'm going to specify total sales. We know that we need to take the sum of amount, right? So we did the same in Excel and SQL as well. We'll do the same in Power BI also. Now we need to break the filter context, right? So we'll specify filter and we will specify all. So what essentially we are telling Power BI, any filter context that is applied on this table, remove that filter context and we are going to explicitly apply any filters in this measures, right? So I'm going to specify the table name. And then the first thing that we need is we need to make sure that our data is partitioned by the employee ID. So we only want the data for specific employees, right? Or the selected value of the employee ID in that particular row. So we are going to specify the row employee ID would be equals to selected value of the employee ID. And I'm going to go into the data view and explain it a little more in a moment. We know the other filter that we need is that the date we have, it should fall in the last 7 days, right? So we are going to specify and the sales date should be greater than equals to selected value of sales date minus 6. We did this in both Excel and Power BI as well. And finally, we are going to specify that the sales date should be less than equals to selected value of sales date. Okay. And with this, our measure should function as expected. Let's specify that. We know that 543 was the value for the most recent sales date for employee ID 100. That is the case. That means our measure is working correctly. Now let's look behind the scene what exactly happened. So for a specific day, let's take the example of employee ID 100 on sales date 16th of September, right? So essentially, Power BI was doing a sum of these two rows to give us the amount. But for the cumulative sum, we do not want that. We want all the filters to be removed, right? So what we said, okay, remove all the filters. And now for that particular row, we have the entire data set. And then explicitly, we applied those filters. So we know that the employee ID is 100 and the sales date is 16th. So the first filter we told Power BI is, I only want to consider the rows where the employee ID is 100, right? And then from there we moved and specified that only give me rows, right? Only give me rows where my dates are between 6 is on or before 16th and is on or after 10th, right? So we explicitly told Power BI this, that for every row, identify the employee ID and the sales date and apply this same operation and then do the sum. This is how things are happening in the background to achieve this particular result. Okay. So now we have solved this in Excel, SQL, and Power BI. Let's solve it finally through Python and Pandas. So now we are going to perform the exact same activity, but this time we are going to use Pandas and Python. We are going to use these steps in order to achieve the same. First, we will import the Pandas library. We'll read the CSV file. We'll convert sales date to date time. Then similar to what we did in our Excel and SQL, we are going to group by employee ID and sales date. We are going to take the sum of amount and we'll call it sales. Followed by that, we are going to sort the data frame by employee ID and sales date, and then we'll calculate the rolling 7 days sum, which will be our cumulative sum. And finally, we'll print the data frame and that will be our result. Okay, so let's go ahead and get started. I'm going to import the pandas library. I'm using Notepad++ to code it, and then I'm going to execute it using command prompt. You can use anything else as well. Now, once I've done this, I have to read this and allocate it a data frame. So I'm going to specify pd.read_csv, and then I'm going to specify the name of our file. The name of the file is day1salesdata.csv. Now we need to convert this sales date to date time. For that, I'm going to specify df sales date is equals to pd dot to underscore date time. And let's capture this one more time. Let's quickly print our data frame to ensure we have not made any mistake as of now. So we will switch to our command prompt and let's quickly see if everything is running as expected. So I've specified the Python keyword and the name of the file, and we have the 4 columns, 1000 rows, and the index column. So everything looks good. Let's go back to a Notepad++ and code this further. So now we need to create a new data frame. We're going to call it grouped underscore data frame, right? And we are going to group by on the basis of employee ID and the sales date. So we are going to specify employee ID and the sales date, and we are going to take the sum of the amount, right? So we are going to specify amount dot sum. I'm going to reset the index because we are doing group by, that is going to reduce the number of rows. So we are going to reset the index. Also, let's change the name of the column from amount to sales, right? So I'm going to specify rename columns is equals to, then I'm going to specify the initial one, which is amount, right? And the new one, which would be sales. So let's quickly go ahead and print this as well to ensure our code does not have any syntax error. I'm going to switch to my command prompt one more time. I'm going to run it and everything looks good. This is our new data frame. It has 534 rows, 3 columns, and everything looks good. Now we have to sort it on the basis of employee ID, sales date, and then we'll calculate the rolling 7 days sum. So let's go back to our Notepad++. So now we are going to sort this data frame, right? We are going to use sort underscore values. We are going to sort by, then we're going to specify the 2 columns, employee ID and sales date, and then we are going to specify ascending is equals to true. So in the previous examples, we had used sales dates to be descending, and we are going to do that in a moment. It's just that the rolling function expects the date to be in ascending format, otherwise it will fail, which is why we have kept it as true for now. Okay. So now let's go ahead and add our rolling sum for the last 7 days. So we are going to specify our data frame, which is grouped underscore df. We are going to name the new column 7 days sales, right? And then we are going to group by this data frame on the basis of employee ID, right? We are going to group by on the basis of employee ID, and then we are going to apply a lambda function. So we are going to specify lambda. Here we are going to set the index to sales date. This will ensure that the sum is calculated correctly for the last 7 days on the basis of sales date, right? We need to take the sum of sales. So we are going to specify sales, and then we are going to apply rolling. It should take into consideration the last 7 days. So we will specify 7 day, and we will specify the minimum periods as one. So even if there is 1 day in the last 7 day where we had sales, we should consider that. And finally, we are going to take the sum of all these rows, right? So what is happening in this row? For every single row, we are looking back for the last 7 days on the basis of sales date column. and we are taking the sum of sales. Okay. Then we are going to reset the index and we will specify drop is equals to true. Okay. After this, let's sort this one more time before we actually print it, because we know that for employee ID 100, for the maximum date, the value is 543. So this should also result in 543 if we have coded it correctly. And I'm going to print it now. Let's go back to our command prompt and see if everything is fine or if we have made any syntax error. So I'm going to go back to my command prompt and let's run it one more time. And now we are getting the values that we needed. So you can see that the 7 days sales is coming as 543, which was the expected result. So with this, we were able to solve this problem statement using first Excel, then SQL, then Power BI, and finally Python. Thanks a lot guys for watching this video. If you are still watching it, please consider subscribing and I'll be posting more videos soon.